Hey nerds, Todd Simmons coming back at you with a little more Toddomation. So welcome to video 4 in this new series on how to create your own lab on your own device without needing much connectivity at all once you get it all set up. So in this video, I want to talk specifically about the CLab topology file. This is what actually runs the lab or builds the lab. Everything gets built from this particular file. So it's important to understand what the file's doing. And one of the reasons why I wanted to provide you a file and didn't want you to have to write your own file. Now, I've created a pretty good topology for you with 10 devices. Now, you might not need 10 devices, so you can, take things out as you see necessary. But what I did want to do is at least give you enough to start with so you can do a little more than just, 2 switches with the lab or 3 switches with the lab, right? So this is going to get you a little further, hopefully, with your studies or your labs or the environments that you're working on. So at this point, you should have an understanding of Arista and how things work. And this video is specific to the ContainerLab topology file, and I'm calling it topo.clab.yaml. I'm going to minimize my terminal window here. This is the same terminal window that we just finished with in video 3 when we created our Docker image. But before we actually take those Docker images and have ContainerLab build, I want to make sure that you understand the file. So there's 3 main sections. One is just the name. It's pretty simple. It's going to be the name of the lab when it creates it. So this one, I called it ContainerLab. Pretty simple. The next is the management, which has a network, and I'm calling it CLab-management. You can call it anything you want. It really doesn't matter. But what's important is you give it an IPv4 subnet. And these, key value pairs associated with the YAML on these, they do need to be perfect. You can't have an IP4 subnet without a /24 or /16, whatever size you want to make it. I just start with the easy button of 192.168.0.0/24, which means that, we're going to start from the .1, go all the way up, possibly to .254. Now, you have to specify the IP addresses of these devices, okay? This is just the subnet that it's going to use. By default, the ContainerLab itself, the interface will assign itself the .1, the first available IP address. That way you can actually reach the devices inside the lab. So the first 2 sections are pretty easy, pretty self-explanatory. The topology, that's where everything lives, right? Now, if you don't have a name and you don't have the management, it's not going to work. But the topology is exactly what it sounds like. It is the network topology that you're going to be using. It is the actual devices. And they're not called devices inside your network topology. And I'm going to start to roll this down, but I didn't, want to have everything on the screen as you saw it in the past couple of videos to start. So when we look at the topology in VS Code, I'm going to roll this down. The first thing that we look at from the last video when we created our actual Docker images with the import command, we have the kinds. And right now, the only kind that we have, and what's great about Arista is, CEOS, they only have one operating system. They don't have 4 or 5 different operating systems like some of the other OEMs do. So when we do the kinds, and it's just saying that the kinds of devices that are going to be here, this first entry, the Arista CEOS, now that is a key. But the key is actually a variable. You don't have to say Arista CEOS there. Now, I would recommend keeping it that way because that makes it pretty easy. The image key and the environment underneath there, those are required elements. The image, the value associated with the image key is going to be what you're making the Docker image named. I didn't say that very well. The name of the Docker image when you imported it. Very important that matches. We're going to use this Arista CEOS as a variable, and you'll see that here in a minute, on the actual devices. Now, the environment that we're creating is I'm creating a management network, okay, the environment, so management, that's actually going to be a VRF on-side. In the devices themselves, and the VRF is going to be named management. That's where I'm going to put the MA1 or MA0 interface for the devices to be able to reach. That way the management is in a different VRF than the default VRF, so we don't get things confused inside there. So the topology, the kinds, the Arista COS, right? Very, very important that we name that properly. And then the environment, you can make this anything that you want, but I would recommend just keeping it the same at this particular point until you get more used to it. Now, notice there's two more sections, and that's under topology. Nodes. These are all the switches, and you're going to see that I created 10 switches in this particular topology. And then the links. How do the devices connect? Okay. Very, very important. You actually have to specify in your topology file, which makes perfect sense, how they're connecting. So let's drop down and we'll look at the nodes first. So I told you, I gave you 10 nodes, and I'm going to make this just a little bit smaller. So border leaf 1, spine 2, leaf 1, leaf 2, leaf 3, leaf 4, and then connected host 1, host 2, and host 3. 10 devices. Notice that the indentation, this is a YAML file, so this indentation matters. If you don't get the spacing right, at least you have to keep it uniform, you're going to have a problem. So don't think that you can just put nodes in here and then it's going to work. You have to maintain your spacing. Once again, that's why I rolled everything up, and now I'm rolling it out one piece at a time. So when we look at our nodes all need to have some of the same basic information. So I'm going to start with this border leaf 1, and I'm going to roll it out. Kind, once again, very important. You're telling it what operating system or what Docker image to use. Now, you can have multiple Docker images and specify the different kinds here. This, once again, is just to get you started. Okay. I've created it in a group called Leaves, makes it simple. The management IPv4. By the way, these keys are required. You can't change the keys. So the values are potentially different keys inside the YAML or variables that I created, like the leaf. Notice the management IPv4 inside the management burp that's created on the MA or management 0 interface. That's the IP address. That's how it's going to contact it. You're actually going to SSH to these devices. Okay. Now, if you don't have enough memory, I have plenty of memory on my device because I want to make sure the video goes smoothly. But if you don't have enough, the startup delay is going to be your friend. Okay. You can maybe, if you have 8 gigs of RAM, you might only be able to start up 1 or 2 devices at a time. So what you want to do is use the startup delay. So for border leaf 1, if you say 10 seconds, it's going to wait 10 seconds before it starts. But if there's no startup delay on any of the other devices, as you're going to see in mine, and I'm going to go ahead and roll down spine 1, the startup delay is 0. It's immediately, as soon as the ContainerLab starts to load this topology file, it will start. It'll import that device. Not import. It'll take that Docker image that we've specified and immediately start to spin that up. Once again, there's 10 devices. The Docker image is 2 gig, right? It really wants 20 plus gig to be able to do this without a pause. If you put the pause in there, this is what allows you, if you're memory constrained, to be able to have more devices. It doesn't need that 2 gig the entire time, but it certainly needs it as it's starting up. Okay. So if you don't have enough memory, you want to do your startup delay and just start to look at it. I would recommend not having any more than 2 devices. If you're memory constrained, you're at 8 or you're at 12. Even if you're at 20 gigs, you probably only want 4 devices starting up at once, which means each one of the devices, when you create them, is going to take anywhere between 60 and 120 seconds, depending on your machine. So you might have a startup delay for your very, very last device. It might be 300 or 500 seconds later. This is in seconds. So you'll want to use the startup delay to your advantage, and you might have to play around and test it based on the amount of memory that you have. Okay. The next thing after the startup delay is the startup configs. This tells CLab or ContainerLab where to get the config. Now, I've provided the startup configs for you. Okay. And as you can see, it's just specified the init configs directory, which is right here. The DC1 folder, which is right here. And then borderleaf1.cfg. borderleaf1.cfg. So just to look at it, because they're literally all the same real fast, is I don't have enabled passwords. I don't have any AAA on the root, which means you can get to root access immediately. I don't have a password assigned for root. Once again, this is a lab environment. This is on your device. I'm not meaning to secure it. I'm just trying to make it easy for you to access. Then you do everything that you want in the lab. Okay. The AAA auth exec default local, right? AAA auth commands all default local, just basically opening it up so you can do anything that you want. Username admin, privilege 15, right? Super user. Role network admin, no password. So you're going to be able to SSH to this thing, okay, without having a password. You just need the username admin. When you SSH to it, where do you SSH? Well, the management address. Notice the management address isn't listed here. It's going to be assigned by ContainerLab during the creation of the actual switch itself. Okay. And then the base config that I put, service routing protocols, model multi-agent. I would imagine most of us are doing, multi-protocol BGP. Therefore, we want the multi-agent to be spun up. I'm giving it a host name, and that's it. That's the whole config file. That's what it's going to start up with. You can start it up with anything that you want. Right? This is enough. It's going to get you going on the device. Now, if you're like, well, what about this Ansible username, Todd? I left all this plain text so you could see it. Once again, this is a lab environment for you. This is not meant to be secure. I am not deploying this configuration. Now, that secret password that right now is Ansible for the username Ansible will be encrypted as soon as it's loaded onto the switch. But once again, this is just for you to get going. So I'm going to go ahead and close that config. We're going to go back to our topology file. Ports. This is great. This is what really is going to help us out if we want to use our own SSH client. I'm very particular to using my SSH client, which I always use Secure CRT. I've been using it for 20 years. Okay. It allows us to do port forwarding, and that's what ports mean. So what it's saying is this port forwarded will be forwarded to this port. So when I set up my SSH client later, or if you've looked at the GitHub, right, where we did the VPN into code spaces, this means that the device is going to be available on 2051, and ContainerLab will forward it to the device on port 22. Okay. If you do 2222, well, you only have one local port of 22, so you're not going to be able to SSH to all these devices. I like to kind of keep a standard with things. So whatever I use for the management address, the last two octets, I like to make it 20 and then 51. If you got a lot of devices, you got a lot of memory, it could, if you're using 151 for the management IP or 192.168.0.151, you can make it 2151 here. But it all needs to, and I made a little mistake there, it all needs to forward to 22. Why? Well, the Arista devices by default are listing for SSH on port 22. You don't have access to the device to be able to change any of that initially. You can change it if you want afterwards, but it's not going to work if you don't port forward to that port. Now, do you have to do this? No. If you want to use an SSH client and don't want to have to go directly to the terminal on your Linux machine, then yes, you have to forward the ports. And if you don't forward a port to port 22, and understand, with the ports, and notice it's a list. You can have multiple ports. If you want to forward to 443 and you want to start doing the EAPI, which, maybe I'll make another video on if people ask for it, you could do a different port :443, or maybe you wanted to do it on port 80. I wouldn't recommend it, but it would be whatever that port would be to .80 on the device. Because OrbStack is running on your computer, all of the connections are going to go to the same IP address. That's why the port becomes so important. Understood? All right, so hopefully we're good to go on ports. Now, notice that DC1, Spine 1, there's no difference except for the management IPv4, okay? The location of the startup config, possibly the startup delay, and then the ports. Once again, if these ports, if you use the same port, forwarded and local, you're only going to be able to hit one device at a time. So it's very, very important that you're using a different source port to go to this destination port. And at that part, that's all the nodes. If I start to roll out the other nodes at this point, you'll see they're not changing. It's literally the same thing over and over for each one of those nodes, all the way down to host 3. I'm telling it, right? The group might change, and the group doesn't mean a whole lot as far as the way ContainerLab works. That helps us actually set up the topology file if you want a visual representation for it. But, the management IPv4, right? The startup delay, the startup config, those are all pointing to the respective folders, and I've provided you with all of that. You shouldn't have to edit any of those files to get started on this lab. You should be able to take this topology file and these configs that I've provided, and you should be able to get your lab running immediately. The only thing you're going to have to play with is if you're memory constrained and how many devices. So if you want to know, well, Todd, I don't need all those devices. Great. Two things you can do. Okay. You can just comment them out using VS Code, right? That's commented out. It's not going to build that instance if you don't want to leave 2 or you don't want to leave 3 or you don't want host, right? Just comment them out and ContainerLab will ignore them. You can delete them if you want, but as you're getting to use ContainerLab and you're getting used to these topology files, I'd recommend keeping them there just for representation. Okay, so there's all of our, I'm going to go ahead and roll these out just to show you that all of these devices are listed in the same manner, but they have some specific information, right? The IP, the startup delay, the startup config, and the ports. Okay. Now, we haven't actually connected the devices, so we have to connect them. That's what the links subsection is. Very, very, very important subsection. Okay. And in the links subsection, I've created all of the links for these particular devices. You'll be able to see them or connect to the devices using LLDP to see what they look like. Very, very important. And I put comments in here to help you. So you have to use, it's a list format, by the way, if you don't know what I mean. A dash inside a YAML file in this format is a list. So this is a particular list and it's got a dictionary inside of it. Okay. What are the items? It's telling you that DC1, okay, these are the actual names of the nodes. So as we scroll up, look, DC1, and it's actually the leaf where I'm starting with. So DC1, leaf 1. You can change these names all you want, but you better change the links below on the device types when we do that. So it's saying this device name, colon, and the colon afterwards expects an interface. So it's saying that Ethernet 1 or ET1 on DC1 leaf 1 is going to connect to DC1 leaf 2 on its Ethernet 1. Pretty simple. I mean, I would imagine if you're at this point, you're doing lab, you understand layer 1 connectivity on Ethernet ports. This is how you connect them. I've arranged them in a way that makes sense to me. You can arrange them any other way. If you want to have additional interfaces, well, you just add them here. Okay. Notice I have leaf 1, ET1, and ET2 connecting to leaf 2, ET1, and ET2. Why? Well, I'm probably going to create a port channel for an MLAN. Okay. Then I go and say leaf spine. Okay. So the way that I've set this up, you can make this a layer 2 leaf spine, a layer 3 leaf spine, any way that you want. There's no configuration on here that's going to tell you how to do that. Okay. So at this point, I've got DC1, leaf 1, Ethernet 3. Now, here's an important fact. You can't reuse the same Ethernet interface twice, just like you can't reuse the same Ethernet interface twice in real life. Okay. So you can't reuse 1 and 2. You've already used it. So the next interface must be 3 and 4. And as you can see, leaf 1, ETH3 goes to DC1, ETH3. Correct? And ETH4 goes to DC1, spine 2, ETH3. And I didn't specify previously it was spine 1. But these are the node names. These are after the colon. These are the interfaces that they're connecting. Now, if you get this wrong and you have something that's not connected, ContainerLab is going to tell you, and they're going to tell you exactly what interface. If you've reused an interface, ContainerLab is going to tell you, you can't do that. You reused an interface, and it'll tell you the interface, just come in here, find the interface, and correct it. So the way that this has been configured, okay, is it's a layer 3 leaf spine. Why is it a layer 3 leaf spine? Well, I didn't actually create peering between the spines. It's available. Notice I don't start spine 1 or spine 2 until ET3. So if you wanted to create a layer 2 leaf spine, and if I'm confusing you when saying that, don't worry about it. You could actually go DC1 spine 1 ETH1 the same way that I did this. So this is why I leave these in here. If you wanted to do this, and you wanted to create additional links that weren't here, I would just select it. You can copy it, put it in here, okay? And this time, instead of endpoints, we could have said spine 1, and I'm just going to copy spine. I'm going to leave spine 1 down here too. So I'm going to say spine 1, right? ETH1, ETH2. And instead of leaf, I could have said spine 2, just copying the spine over because that's the node names, okay? ETH1, ETH2. This will create a link that I could use between spine 1 and spine 2. Okay, pretty simple. Okay, I'm going to go ahead and just delete what I did in there, but that shows you how you can create the links as long as you haven't used the ETH interface. And I've spelled them out ETH1 just because that's how I did it initially. And I realize I'm saying ET1, ET2, but understand they're one and the same. Okay, so here's all of my links. So these are my leafs to my spines. Okay, notice leaf 1, leaf 2, leaf 3, right? ETH 3, 4, 5, and 6. I like to keep things the same. Okay, yeah, whether that's how you're doing it or not, this makes it easier for me to track to make sure that I haven't used the same node and the same interface connecting to different nodes. Okay, and then here's my border leaf peer links. And notice it says spines to border leaf, and it's not actually peer links. I'm going to remove them. Well, it's just links. They're not necessarily peer links. Well, we can leave it there. And I say DC1, border leaf 1, ETH3. Once again, you can add another border leaf. Call it border leaf 2, and then connect border leaf 1 and border leaf 2 using ET1 and ET2. So I've kind of created a topology that allows you to let it grow here pretty quick, pretty simply. Anyway, so ETH3 and ETH4 on border leaf 1. We're going to ETH7 on spine 1 and ETH7 on spine 2. Okay. And then our leaf to host mappings, I have leaf 1 and leaf 2. Since I created them in an MLAG, I created the connection to this DC host 1 from leaf 1 is on Ethernet 1. From leaf 2 is on Ethernet 2. Why did I do that? Because I'm probably going to create a PO to demonstrate how an MLAG works down to a host. Okay. And then leaf 3, leaf 4, okay, I've actually created those into the host 2 and host 3. Obviously, those are single home. There's no MLAG there, right? Leaf 3, leaf 4. Now, that doesn't mean that you couldn't do something, but if you wanted to add, if you said, hey, Todd, layer 3 leaf spine, great. Now I want to do an ESI. So I don't need to have a port channel in between leaf 3 and leaf 4, but now I want to create an ESI for them. Great. Well, all you would need to do is this. You would copy that endpoint. Okay. And leaf 3, ETH7. Okay. Well, you can't redo leaf 3, ETH7, but we could do 9 to DC1 host 3. Sorry, host 2. ETH2. So now look, we have the host 1 up here. Now we have host 2 from leaf 3, and this would obviously be leaf 4. Okay, host 2, ETH1, ETH2. We haven't reused them. Okay, and this would be probably 7 as well because we're going to use that one. Okay, and then I can copy this one. That's going to give me my leaf 4 stuff and say this would be ETH3. This would be leaf 4. And these would both be 9 and 9 to host 3. This would need to be ETH1. And then this would be ETH2. So notice I just added links. I didn't change the number of switches that I had, but I just changed the number of links that I had. And that allows me to change the structure of my topology. Okay. So I'm going to just go ahead and roll back that because I want to start pretty simple. But what I'm trying to show you is you can use what I've given you here, okay, as a guide and start to create how you want to create. So at this point, that's the topology file. You don't need to change it at all. It's going to work exactly the way that I've configured it, but I want to make sure that you understand the different pieces and parts. That way, when you want to design your own lab, or if you're like, hey man, I don't need 10, I only want 6, or you know what, 10's not enough, I need 26 devices. All you have to do is take what I've given you as a template and just adjust that template. Now, I would change the name as far as the templates, right? You might have Topo 1, Topo 2. The name of it doesn't matter because we're going to specify the name, and I'm going to show you that in the next video when we actually create the ContainerLab lab environments, right? You can have as many topologies as you want because when we create the lab, we specify which topology we're going to use. So that's it for this lab. Hopefully you have a better understanding of the topology documents, the topology files, that are in YAML. And the more that you start playing with it, right, the quicker that you're going to get and the more that you're going to understand. But if you have any questions, feel free to reach out. I can definitely take a look at your topology files, the YAMLs themselves. If you can't get around it, if it just doesn't seem to work, and I'll definitely help you out. Just, give me a quick subscribe and, put a comment on there and I'll certainly help you out. Anyway, hope you're enjoying this. Our next lab is going to be the fun one. It's where we're actually going to create the lab now that you understand the topology file. So talk to y'all later, nerds. Bye.